Hello, Mayfield Grade 10 math students. Today we're going to be doing our next lesson in academic math from Unit 2, quadratic equations. We're going to be learning how to complete the square. So if you remember our last lesson, we did, if we go back to this, we worked with the factored form of the quadratic equation. Uh, we learned how to take that equation factored form, pull out the x-intercepts, which is quite easy, and then graph it. And then we also learned from the factored form, we actually find the vertex. Okay, so um, fair bit of information we can get from the factored form if we know what to do. So today what we're going to be doing is, if you remember, we had the three different forms. So you have to be prepared to be given any one of these three forms, and the goal over the next couple of weeks will be I'll give you any possible form, and you can tell me everything about that parabola, the vertex, the x-intercepts, the y-intercept. You can graph it, and then once you have those skills, then we're going to be looking at some word problems. There's a lot of really useful applications. They're not invented ones. They are actual quadratic word questions. Okay, so that's our goal. Learn how to pull out information from any one of these, and sometimes what we have to do is actually convert from one form to the other. So by the end of this unit, you'll know exactly how to convert between all the different forms, and based on that, you can get any piece of information you want. Okay. Vertex, x-intercepts, y-intercept, direction of opening, stretched compression factor, whether it's reflected, whether the parabola opens up or down. Those will all be available to you once you can interchange between the three forms. So this lesson, completing the square, so what completing the square does is it takes you converts from standard form into vertex form, because uh, if we look at standard form, it really doesn't give us much by itself. Okay, I mean, we could plug in some points and come up with a graph, but if I asked you what's the vertex of an equation in standard form, uh, we'd be hard pressed to know what it is unless you can do this process. So that's what we're going to be doing today. The actual process of converting from standard form to vertex is called completing the square. So uh, that's that's what we do to go from one to the other. And again, here's the definitions of the standard form, the vertex form, and completing the square. Okay, so before we actually get into the process, I want to kind of look at, this vertex form. Okay, so I'll just come up with, I'll just plug in values for a, h, and k. So I'll just say 2x minus 3 squared plus 10. Okay, so that's an equation of vertex form. Uh, and again, you know that the vertex of this parabola is 310 just by looking at it. Whereas if I gave you the equivalent standard form equation, the 3 and the 10 aren't even in here. So if you expanded this out. So I want to look at what this really is here. So that squared there basically tells you you're taking that x minus 3, whatever's in the brackets is squaring, is multiplying with itself. Okay, and if you remember way back earlier in the course, what do we call two binomials that we multiplied together? Well, that is a perfect square trinomial. So basically, uh, perfect square trinomial. So that's what this is. So if you think about it, um, you know, I'm not actually going to multiply this out. I just want to show you. A vertex form is basically the a value times a perfect square trinomial plus another value. So we're going to take advantage of that knowledge when we do completing the square. Okay, so what we're going to do is we're actually going to create, when we go backwards, when we start with standard form, we're actually going to create a perfect square trinomial, and that's basically what the term completing or the phrase completing the square. So we're going to complete the square to make this into a perfect square trinomial. Okay, so if we go back to the lesson note, okay, I'm gonna skip this for now. We'll kind of read this as we go, but I'd rather just start with an example. Okay, so example 1, we've got. I'll just rewrite so that you can definitely see that's in standard form because there's no brackets. There's an x squared term, an x term, and a constant. Okay, and we want to turn it into something that looks like vertex form. Okay, okay. So I'm going to take a peek at this process. So first thing we do is we group the first two terms. So in this case, that's the x squared and the 8x. So when I say group, I just mean put brackets around them. So keep them kind of on their own little island. And if there is a coefficient of x squared, I want to factor that out. So in this case, the coefficient is, in this example, is just 1. So I don't really have to factor that out. So first step is super easy. Just put brackets around the first two terms. And the plus 5 is outside the brackets. Okay. Now if that had been a 2 there, I would have said, okay, I'd write it with the 2x squared plus 8x, then I'd factor the 2 out like a common factor. Okay, the next example we do will have that, but in this case we didn't have to do it because it was just x squared. Okay, so here's where what we're going to do is complete the square. So that's a little, there's a little formula here. So it says make a perfect square trinomial inside the brackets. So we're basically creating a third term here that will make it a perfect square. So what we do is we take half the value of the coefficient of x. Sorry, take half the value of whatever that coefficient is. So in this case, that's a 4. Half of 8 is 4, and then we square it. So 4 squared is 16. So if I put a plus 16 inside here, that would actually be a perfect square trinomial. That's actually would be x plus 4 all squared. So this is the quick formula. Take half the value of the coefficient of x and square it. Okay, so inside the brackets, okay, half of 8 is 4. 4 squared is 16. So I add it. Whenever we square it, it's always going to be positive. So this is always going to be adding 16. Now, you guys know from previous math courses that I can't just add a 16 here and think that everything's cool, because it wouldn't be balanced anymore. It's basically adding 16 here but not here. So what we actually do is, this is what we want. Okay, now in order to offset the fact that I just added 16, I'm going to subtract 16. Keep that inside the brackets. And so all we did between here and here, take half the value, square it, add and subtract it inside the brackets. You're probably thinking, well, why bother doing that? That's just 0, right? Well, we're going to treat these two separately. We're not going to combine them inside the brackets. Okay, so the next step here is we're going to get rid of this term here, the one that we had to add in to offset our adding of 16. We're actually going to send that outside the brackets. Okay, I call it taking out the garbage because we don't want it in the house. We're going to take the garbage outside. So in this case, all we have to do is move it over here. So I keep the 16 and then I close the brackets and the 16. I'll keep the 5 first and the minus 16 outside here. And you might be saying, well, why didn't we just send it out here in the first place? Why did we bother with this step? Well, you're going to see if I had a coefficient that I'd factored out here, which you'll see in the next example, before I can take the garbage out, the negative 16, the minus 16, I'd have to multiply it by whatever was here first. Okay, so in this case, it didn't change because there was no factor outside, so it just comes straight out. Okay, so now the last part, basically, we're almost done. This is the last step here. So we do two things. Okay, we recognize the fact that this is a perfect square trinomial. We created it. Okay, and that's one thing I haven't mentioned yet. You can always create with an x squared term and x term. You can always find the constant you need to make it a perfect square trinomial. So in this case, it was the 16 we needed. Okay, so so I'm going to replace this perfect square trinomial. So you remember a perfect square trinomial is just a binomial squared. And since it's x squared, I know the first term is x. Now, how do you get the term? There's a second term here. Well, this is almost sort of going backwards from how we created the 16. So remember, the first thing we did with the 8 to get the 16 was divided by 2. So that's all we do. We take that plus 8, positive 8, divided by 2, we get a plus 4. Okay? So, and if you actually expanded this separately, you'll see that x plus 4 all squared is equal to x squared plus 8x plus 16. Okay, so we're just changing it from a perfect square trinomial to a binomial squared. And the only other thing we have to do now is just combine these two constants. So 5 minus 16, that's minus 11. And we're done. So this is now in vertex form. Okay, and if we wanted to know the vertex, we could just get the h and the k values here. So don't forget it's x minus h, so h is negative 4, and k is negative 11. So the vertex, if we were asked, we weren't really asked here. If we were asked to get the vertex, we just look at the vertex form and pull out the h and k. So that's how that works. Okay, I have one more example here, and then I'm going to challenge us to a more difficult one. Okay, so this one will be a little trickier than the first one, but basically the same process. So this time our equation, you can see that it's got a 2 in front of the x squared. So that will, you'll see that that's going to play into making us do an extra step here. So first thing we do, we put brackets around the first two terms. Probably an easiest step in math, just putting brackets around a couple of terms. Now, now we actually have to factor out the coefficient of the x squared term. So in this case, it's a 2. So I'm going to rewrite this as 2. So I'm factoring the 2 out. Now don't forget I'm factoring the 2 out of both of these terms. Okay, so whatever, I'm always going to pick the number that's in front of the x squared as my factor, my common factor. And when I divide, so basically now I just divide each of these two terms by 2. So I get x squared plus 6x. And then the plus 11 from before. And the question I always get in class is, but sir, couldn't we just factor a 2x out of here? Well, you could, but that's not part of the process of completing the square. So you only factor out the coefficient of x squared, and you'll get an x squared and an x term in the brackets. Okay. Now the rest of it is very similar to what we did in the first example. So the first thing we do is we want to make this into a perfect square trinomial. So if you remember, the way we got that third term, take half of 6, which is 3, and we square it. So 3 squared is 9. So if I add a 9 there, that is a perfect square trinomial. That's what we're trying to get. And then again, to offset that, we have to subtract, we have to undo what we just did. and then the 11 is outside. And now we do the taking out the garbage step. So basically I'm going to take that -9 and send it outside the house. Now, when we do it this time, let me just, so when I do it now, okay, I can't just put a -9 here because that 2 is really multiplying with that -9. So before I can take it outside the brackets, I have to multiply it by any factor that's outside here. So basically 2 times -9 is -18. So taking the -9 out, I have to multiply by the 2 first. Okay, and now again we're at the last step. It's not that bad. So we do two things here. One, we change this perfect square trinomial into a binomial squared, and we also just combine those two. So notice the 2 is the same all the way down. When I change this to a binomial squared, I can get that already. It's always going to look like that, and then it's just figuring out what number goes here, and that's always half of the coefficient of x. So half of 6 is +3, and then put these together, I get -7, and we're done. So that's the vertex form. Now to get the vertex, because this question asked for the vertex, find the vertex of the problem with the equation. So that should be, a light should come on that says, oh, they want the vertex. That must mean I need to get the vertex form, which means completing the square. They didn't actually ask us to complete the square. It's kind of implied. Okay, so the vertex is, don't forget the sign here. It's x minus h, so x is -3. So there's the coordinates of the vertex. So that's how completing the square works. This is a very important skill for you to do, and you need to practice it. I've seen lots of students think that they know how to do it by looking at a couple of examples I do, but there's a lot of mistakes made if you don't practice, especially factoring out the 2, figuring out what number goes here, changing this back, okay? The other question I get asked quite a bit is, sir, sir, what happened to the x squared term? Because this is just x. Well, if you expand this, you get this, and you create an x squared term. So I see lots of mistakes where students will get confused and go, well, I need to have an x squared here, so I guess that should be x squared. No, this is a binomial squared, so it's just x plus or minus a number squared. Okay. All right. I'm going to just, sorry, I'm just going to end this. I'm going to take a random standard form equation. We'll see how this works out. So I have no idea what that parabola looks like. I do know that it opens down, but I don't know much more than that. Well, that's a bit of a lie. I also know that c value is the y-intercept. We haven't talked about that a lot, but so I do know the y-intercept's -7, that it opens down, but in terms of x and x-intercepts and vertex, don't really know much about it. Okay, so I'm gonna complete the square here, turn it into vertex form so I can at least get the vertex. And completing the square always works. Okay, like I said, I just did this randomly, and I'm going to be able to convert it to vertex form. Factoring, as you know from before, doesn't always work, but this process always does work. So let's do our steps. So first step, put the first 2 terms in brackets. Okay, nice and simple. And then the next step, factor out the coefficient of x squared. So that happens to be -3. So that means divide both of these terms by -3 because I'm factoring that out. So this is always x squared. And this time I got +6x divided by -3. That's -2x. Okay, and now we're going to complete the square. So we're going to add that third term inside the brackets. That makes this a perfect square trinomial. So this is actually easier than I thought. I was hoping I would get a fraction, but not this time. So I take half of -2, that's -1. I square it. -1 squared is 1. So I add 1. There's my perfect square trinomial. But I have to offset what I just did by putting the -1 inside. And don't forget about the -7 that was already there. So now I take the garbage out. Okay, so that means taking that term outside the house. So before I could do that, I just can't write -1. This time it's a minus -3 that's being multiplied with that. So -3 times -1 is actually +3. Okay, so sometimes it turns into a positive when you take it out if that's a negative value in front. And now last step, turn this into a binomial squared because this is a perfect square trinomial. The number that goes there is always half of that value, so that's -1. And then combine these two together, we get -4. Okay, and so the vertex is 1, -4. Okay, so this process always works. I was sort of hoping that I might get a fraction here. I just did everything randomly. If you get fractions, you can convert them to decimals only if it's an exact conversion. So for example, if you ended up getting something that was maybe 7/4, right? 7/4 changes nicely into 1.75. You can go ahead and change that fraction. But if it's something like 5/3, okay, as a fraction, you have to leave it as a fraction because 5/3 has a run-on decimal answer on your calculator. If you rounded it to say 1.67, that's close, but it's not exact. So you have to be careful when you do that. Okay, so that's our lesson on completing the square. Very important process, very important skill to have. So that's the last lesson for this week. You will be getting an assignment on Friday during the day, and you will be submitting it for marks. Okay, so that assignment will be based on the 2 lessons we just did this week. Okay, thanks very much, and I hope this was helpful.